Okay, so as in the last video, we have discussed or we have proven the electronic configuration of initial 10 elements of the periodic table, which includes hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Alright, how did we decide that why electron will be going in the 1s2? We derived this, the general term in which the electrons will be going in the first, we derived with the help of this. Alright, initially I told you we have in first shell only one subshell S, so we wrote 1s, and since S holds 2 electrons, so 2 on top of it. Then in second shell we have two subshells S and P, so 2s 2p. S holds 2 electrons, P holds 6 electrons. Then in third shell we have three subshells 3s 3p 3d. S holds 2 electrons, D holds 6, P holds 6 electrons, however D holds 10 electrons. Then last but not the least was fourth, the fourth shell, in which there are four subshells present: 4s2, 4p6, 410 4d10, and 4f14. Alright, so this was our general term in which electron would be going in the first. So with the help of this, we have our electronic configuration of initial 10 elements of the periodic table. Initially we discussed about hydrogen. Hydrogen's electronic configuration is 1s1, then helium 1s2, lithium 1s2 2s1, beryllium 1s2 2s2, boron 1s2 2s2 2p1, and carbon 1s2 2s2 2p2. Then nitrogen 1s2 2s2 2p3, oxygen 1s2 2s2 2p4, fluorine 1s2 2s2 2p5, and neon 1s2 2s2 2p6. Alright, now we are going to derive the electronic configuration of the next 10 elements of the periodic table, which means from 11 to the 20th element we're going to derive the electronic configuration of those elements of the periodic table. Alright, so initially we are going to start with the nitrogen. Not nitrogen, however, sodium. Na is the symbol of sodium because sodium is represented with Na. Alright, so this on the top of it, the thing is written is nothing but it is the atomic number. And we have initially discussed that atomic number is equal to the number of electrons. Alright, number of electrons. Alright, if sodium has 11 atomic number, which means sodium has 11 electrons. Alright, so how we going to make its electronic configuration? Let's see. Alright, initially our electrons would be going in 1s2 because we have our general form. Alright, initially electrons would be going in 1s2. So yes, I'm writing here 1s2. Then it has to go to 2s2. Okay, 2s2. Then it has to go to 2p6. Okay, 2p6. Alright, now let's count the electrons. 2 plus 2 4, 4 plus 6 10. And we already know that we have 11 electrons in the sodium, and only 10 electrons have been occupied by these three subshells. Now only one electron is left. Now we need to see which subshell we need to open. We need to open 3s2. After 2p6 we have 3s2. So here 3s, instead of writing 2 we're gonna write 1, since we already know we have only one electron left. If we would have two electron left, then we would have made 3s2. However, we have only one electron left, that's why we have written 3s1. Now let's count. 2 plus 2 4, 4 plus 6 10, 10 plus 1 is 11. Now it is satisfying that 11 electrons would be present in what? In the sodium atom. So sodium configuration is 1s2, 2s2, 2p6, 3s1. Alright, now magnesium. Alright, initially we know that electron would be going in 1s2, then 2s2, then 2p6, then 3s. Alright, we'll see how many electrons will be there. So we know that it has 12 electrons. So 2 plus 2 4, 4 plus 6 10. Now 12 electrons are there, and we have been only occupying the 10 electrons. Means 2 electrons are left, and this would be occupied by this. Alright, so 1s2, 2s2, 2p6, 3s2 is the electronic configuration of magnesium. Alright, now we are moving towards aluminium. What would be the electronic configuration of aluminium? Alright, so 1s2, 2s2, 2p6, 3s2. Now let's count the electrons first. We already know aluminium has 13 electrons. So 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, and only one electron is left. So now let's see which subshell we need to open now. After 3s2 we have 3p6. Alright, so we have 3p. Instead of writing 6, we know that only one electron is left, so 1. Alright, so 2 plus 2 4, 4 plus 6 10, 6 plus 10 plus 2 12, and 12 plus 1 13, and 13 is the atomic number of aluminium, which is satisfied. Alright, so aluminium configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Let's move towards silicon, which has 14 electrons with it. So 1s2, 2s2, 2p, wait, 2p6, 3s2, and 3p. How many electrons would be there? Let's count first these. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, and silicon's atomic number is 14, which means 2 electrons are left, which means p will gonna occupy 2 electrons. Alright, so 1s2, 2s2, 2p6, 3s2, 3p2 is the electronic configuration of silicon. You can count as well. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 2 14. Now electronic configuration of phosphorus. Alright, so 1s2, 2s2, 2p6, 3s2, 3p3. Alright, let's count. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 3 15, which is the atomic number of phosphorus. Satisfying. Alright, so 1s2, 2s2, 2p6, 3s2, 3p3 is the electronic configuration of phosphorus. Now we are moving towards sulfur, which has atomic number 16. Alright, so 1s2 should not write here. I don't know what I'm erasing, however something would be erased. It's okay. Let's erase with this. Okay, now let's write. So 1s2, 2s2, 2p6, 3s2. Let's count. 2 plus 2 4, 4 plus 6 10, 10 plus 2 is again 12. 4 electrons are left, so 3p4. Alright, 3p4, yes. So the electronic configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Now moving towards the chlorine. So 1s2, 2s2, 2p6, 3s2, 3p5. Alright, let's count. Wait for it. Okay, now it's fine. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 5 17. Okay, satisfying. 1s2, 2s2, 2p6, 3s2, 3p5 is the electronic configuration of chlorine. Now we are moving towards argon, and the atomic number of argon is 18. Alright, so 1s2, 2s2, wait for it, 2p, 6, 3s2, 3p6. Alright, let's count the electrons. Wait, here we have 2. So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. So 1s2, 2p2, 2p6, it's 2s2, sorry. I have made mistake here. Here should be s. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6 is the electronic configuration of argon. Now we are moving towards the potassium, which is represented with symbol K. Alright, so 1s2, 2s2, 2p6, 3s2, 3p6. Let's count the electrons first. So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. One electron is left and we need to see now which subshell would be open. 4s2, 1. Alright, so 4s, it will gonna hold only one electron since only one electron is left. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 is the electronic configuration of potassium. Now last but not the least, calcium. So 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Let's count. So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20, which is the atomic number of calcium. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 is the electronic configuration of calcium. So here we ended with electronic configuration of next 10 elements till the 20th element. In the next video, we're going to drive the electronic configuration from 21 to the 30th element of the periodic table. Since we need to see the exceptions, there would be 2 exceptions in chromium and in copper. We're going to see. This was all for today.